Okay, so let's go to the first example of the complex power. So we are given in the sinusoid form V and I. So we are going to solve this one using the complex power formula, that is S equal half V multiplied by complex conjugate of the current. Okay, first step, change sinusoid to phasor. So what is the V is 120 angle 45 volt. I is equal 10 angle minus 10 ampere. But from the formula, we need the conjugate, right? So become I conjugate become 10 angle 10 ampere. Number 2, start to calculate the complex power. Half VI conjugate. So you're going to have half. So now you take the magnitude 120 multiplied by 10. The angle you need to add. So you become which one you need to add? Of course, the conjugate and also the V. So it become 45 add by 10. So you can get here half 100 to 1200 angle 55, or the final answer is actually 600 angle 55. Okay, you can't extract if it is still in the polar form. So step number 3, change rectangular to become polar. So what is the polar form? S equal 600, or you can just use your calculator. Okay, to skip the step, just use your calculator. So it become 344.146 plus 491, J 491.55. Okay, so this is the complex power. So how you can extract the value of the average power? So you know S is equal P plus JQ. So now what is P? P is the average power, that is 344.15 watt. Okay, so what is Q? Q is the reactive power, that is 491.5 VAR. So if you look at here, this is a positive, right? The Q is more than 0, positive value. So if you go to the previous video, so when the Q is positive, this means lag. Okay, so the question only asks you to find the average power. So you just need to write what is the average power, 344.2 watt. Okay, so this is the first example. So let's go through second example. So calculate the power absorbed by an impedance Z. Okay, now let's figure out this in a circuit. Your given V here is 120, the source, right? And you are given the load impedance here is 30 minus J70. Okay, in order for you to find the average power, you need to first find the complex power. So in order for you to do that, you need to find the voltage and also the current. So what you need to do now is to find the current flowing here. So what is the current? Is V over sec. So just divide 120 angle divided by 30 minus J70. So just use your calculator, you can get angle 66.8 degree. So remember the formula, it needs the conjugate. So directly you transfer this one to conjugate. So become minus 66.8 degree. Okay, now you can calculate the complex power. Half VI conjugate. So what is half? V is 120 angle 0 multiplied by 1.57 angle minus 66.8 degree. Okay, so this one you just multiply together. Your angle is means 120 multiplied by 1.57 divided by 2. You got 94.2. So 0 minus, so become minus 66.8 degree. So you can't get any information here. And then third step, change to the rectangular form. So become S is equal, change this one to rectangular form, it become 37.10. Just use your calculator, minus 86.6. Okay, now what is the average power? So this is the average power. So your P here is 37.10 watt. So yes, this is the real power. What is your apparent reactive power? Q. Reactive power is minus 86.6 unit VAR. So when your Q is less than 0 or minus, we call this one leading. Okay. So the question only asks you the average power. So you just need to calculate the P, that is 37.10 watt. Okay, now previous video you learn, previous slide you learn about what you call complex power, P plus GQ. Okay, now this is the real power, this is the reactive power. This is average or real power measured in watt, and this one measured in VAR. Now I'm going to introduce another two type of power, that is what we call apparent power and the power factor. So what is apparent power? So recall back, this is the formula from your real power previously, right? And then what is actually an apparent power? So if we denote P equal, we change this one, P equal, S here is actually the in front one. S equal VRMS IRMS. So this S here is not the same with the complex, just now is the bold S. The bold S. So this is complex power. But when talking about apparent power is the modulus, means the magnitude of the S. This is what we call apparent power. So what is the apparent power? Is equal VRMS IRMS. Okay, so let's see. The second one is what we call power factor. So power factor is the difference between the angle. Okay, so between your delta V minus delta I. So how you calculate the power factor? You just need to cosine delta V minus delta I. Doesn't matter what is the value inside. So if PF is equal to 0, it is a purely resistive, no real power consumption. Sorry, if F is equal to 1, PF is equal to 1, it is purely resistive. Okay, but if your PF is equal to 0, it is either purely reactive for the inductor or the capacitor. But if you have some value, it's around 0.9, 0.8, you're going to have what we call some resistive and some reactive, so it can have a leading and lagging. Okay, so let's see how you define this is leading or lagging. What is the power factor? So the question says here you need to calculate the power factor and also the average power supply. Okay, so first step, you need to simplify the circuit. So it become here, you need to change anything because this is already phasor form. So it become here 6, and here is Z1, there is minus J2 parallel with 4. So what you can get here, minus J2 multiplied by 4 divided by 4 minus J2 is equal to 0.8 minus J1.6. Okay, and then continue to simplify it, so it become plus minus here 30 angle 0, and you have here Z equivalent. So now 6 and this one is in series, so you just add together 6.8 minus J1.6. So in order for you to calculate the complex power, you need to use these two formula, or in this question it's given RMS, right? So you just use the formula for RMS without the half. So now it given here RMS, so you need to calculate the current here. So what is the current RMS here? is equal to V RMS divided by Z. So it becomes 30 angle 0 divided by 6.8 minus J 1.6. So you can get 4.295 angle minus 13.24. Okay. So how you calculate the complex number is actually directly the V 30 angle 0 multiplied by 4.295 angle minus 13.24. So you just multiply the magnitude, you can get 128.85 angle minus this one 0 minus 13, right? So directly minus 13. Change this to rectangular form, so you get 125.42 minus J 29.51. Okay, now let's extract the value. So this is P. So your P is equal, the real power, 125.421. The reactive power is equal minus 29.51 VAR. So if and then Q, when it is minus means it is leading. Okay, and then how you can get the apparent power, the S is equal the magnitude of your complex number, that is actually is equal to 128.85. So this is the magnitude, right? This is the magnitude. VA. Okay. Now last one, power factor. So power factor is cosine this angle, that is minus 13.24. So we can get here 0.9734. So if your power factor is positive, so this means leading. So this here is leading. Or you just stick to one. If your Q is positive, so this means lagging. Or if your Q is negative, it means leading. Okay, so this is the same, leading. So this is how you're going to solve for the apparent power and the power factor.